This is Sebastian Long, ID number 30473669. Okay. So we have an upside down vertex at the bottom cone. That is 30 centimeters high, filled with water to the very top. If you take the cross section of the cone through its central axis and measure the angle of the vertex, it will be 60 degrees. So I'm taking this to mean this angle is 60 degrees. Water starts draining at a rate of 10 centimeters cubed per second. So I'll say that's dV on dt, 10 pi. Okay. We've got part A, show that V equals 1/9 pi h3, B pi h equals 2 at 3 minutes. And we're allowed to use the area of a cone equals pi r squared h over 3. Okay. So first things we want to turn this into this, so we need the radius. We have enough information in the question, so we've got uh, 30, 30, r, and 30. So tan of 30 equals r over h. R equals h. 30 equals h. Sine 30 over cos 30 equals h times half divided by root 3 over 2 equals h times half times 2 over root 3 equals h over root 3. Taking this back into this equation, we have v equals pi times h on root 3 squared times h over 3 equals pi h cubed over 9 equals 1 over 9 pi h3. Okay, so now we want the rate of change when the height is 2 centimeters. So we have dV on dt and we have v, so we can find dV on dt here, equate it to this and solve for the missing variable. So dV on dt equals dV on dt of 1 over 9 pi h cubed, and h is a function in t. So we've got like g of x, where g of x equals x to the 3 is what we have here. So it's just a chain rule, so we go constant stays the same, 3h squared times the derivative of this one, which is just dh on dt. Cleaning it up equals 1 over 3 pi h squared dh on dt. Oops, that's a d. And that's equal to 10 pi. dh on dt equals 10 pi times 3 on pi h squared 30 on h squared centimeters per second, because h is in centimeters. Now to get this, we just plug 2 centimeters into this equation. 15 on 2 equals 7.5 centimeters per second. So this would be negative, but the question asks the rate at which it's decreasing, so we'll give a positive value. Okay, now for the rate at which it's h is changing at 3 minutes. We've got, we know that the volume, we've got the information to find the volume initially, and then the volume at t equals 3 minutes. Yeah, using that information, and then we can plug, use that information to solve for h at t equals 3 minutes, which will give us h, which we can plug into this equation to get the rate of change of h. So we'll do that. So we've got 1/9 pi 30 cubed minus 180 times 10 pi. 30 cubed is 27,000. Yep. Divided by 9 is 3,000. So 3,000 pi minus 1,800 pi equals 1,200 pi. That's the volume at t equals 180 seconds. To find h, 1,200 pi equals 1/9 pi h cubed. So h cubed equals 1,200 pi times 9/pi equals 108, 1,200, 10,800. Yep. So h equals the cube root of 10,800. And then to find dh on dt, we just plug that into the formula for dh on dt. So dh on dt equals 30 on, so this is equal to 10,800 to the 1/3. So 10,800 to the 1/3 to the 2, 10,800 to the 2/3.